morning. Good morning, dear students. A very happy Makar Sankranti to you all. In today's class, we are going to talk about a model question papers, detailed solution, which are already yesterday issued by a PU board. PU first chemistry model question paper, detailed solution. Yes, guys, let us start. See, you all know already the question paper pattern is changed. So 15 MCQ questions came here and 5 fill in the blanks type questions. Yes, let us discuss. So in next coming classes I am going to make videos on particular chapters. Already 6 to 7 chapters videos I have made. If you have not seen the videos, important questions with answers, already I have made a video. If you have not seen the videos, the link is given in the description. Please go through that and then come to this one, guys. Yes, part A, select the correct option from the given choices. That is MCQ type questions. So 15 questions you are having. First question, scientific notation of 0.00506 they are asking. This is from the first chapter, some basic concept of chemistry. So if you want to take a decimal point right side, always multiply 10 to the power minus. See, 0.00506 is there. So if I want to take 3 digit decimal point towards the 3 digit right side, then I have to multiply to the 10 to the power minus 3. See there, 5.06 in 10 power minus 3, which is there in the option number C. I hope you understood. See, second question, Mg2 plus ion is isoelectronic with. What is isoelectronic species? The species which have equal number of electrons, that is called isoelectronic species. See, Mg plus 2, if you take a atomic number, it is 12. Plus 2 means 2 electrons are already eliminated. So if you take electronic configuration, it would be 1s2, 2s2, 2p6, 3s0. That means total 10 electrons should be present. See the sodium, atomic number is 11, and Na plus means it loses already 1 electron, so remaining is 10 electron. That means Mg plus 2 ion is having 10 electron, sodium plus ion is also having 10 electron. Therefore Mg plus 2 ion is isoelectronic with Na plus. I hope you followed the explanation. Third question, the molecule that has zero dipole moment. See, dipole moment is 0 means indicating that the molecule should be linear. See, among the following 4 options, you can easily predict which is linear. Barium chloride, simple it is. See why you are getting. The dipole moment of barium chloride is 0 because the bond dipoles are equal. Bond dipoles are equal means on both sides the bond length is equal and the dipole moment is oppositely side, therefore cancel each other. The bond dipoles are equal and in opposite directions, hence cancel the effect of each other. Therefore net dipole moment of barium chloride is 0. I hope you understood. The spherical shape of rain droplets is due to. Why the rain droplets are spherical in shape? Because of surface tension. You see the explanation. Liquid drops are spherical in shape because they tend to acquire minimum surface area to reduce the surface tension. So whenever the liquid droplets are thrown, they become a spherical shape because they tend to acquire minimum surface area, and which is there only in case of sphere. So they want to decrease the surface tension. That is a matter. The entropy of the universe. This is a second law of thermodynamics. Increases always. Increases. Universe increases and moves towards maximum value. Second law of thermodynamics told that the net entropy of the universe is continuously increasing. This question is based on the statement of second law of thermodynamics. The conjugate acid of O2 minus. Remember guys, already I have made a video on equilibrium, so I have told regarding conjugate acid, base, everything, how to find out. If you have not seen that, the link is given in the description. First go through that. So conjugate acid of O2 minus means if you want conjugate acid, add H plus to O2 minus. When you add H plus to O2 minus, 1 plus 1 minus charge is eliminated, so you are having OH minus. So answer is D. Conjugate acid of O2 minus is OH minus. Addition of H plus to the O2 minus. The strongest reducing agent is. Reducing agent means itself undergo oxidation. Itself undergo oxidation means it will loses electron. When it will loses electron, when it is tendency to release electron very easily, having extra electron. It is there only in case of potassium. See guys, reducing agent means itself undergo oxidation easily, that is loss of electron. K will lose electron easily among others, hence stronger reducing agent. Sum of numbers of neutrons and protons in deuterium is, deuterium has one proton and one neutron, therefore sum of proton and neutron is 2. Simple. Deuterium has one proton, one neutron, mass number is 2, atomic number is 1. Lithium show diagonal relationship with. So if you see the periodic table, lithium is in diagonal with magnesium. Yes, it is. Inorganic benzene is B3N3H6. That is also known as borax or borazine. That is called inorganic benzene. This is the shape of the inorganic benzene, just like a benzene only, but instead of carbon you will have boron and nitrogen atoms here. Only that is the difference. 6H are there, 6 out of 6 carbon you will have here 3 boron and 3 nitrogen. 3 double bonds are there. Everything is same like a benzene only, but there is no carbon, hence it is called inorganic, absence of carbon. The name of this compound B3N3H6 is borazine. What is not an allotrope of carbon? Which is not an allotrope of carbon, they are asking. Graphite, diamond, fullerene, these are allotropes of carbons. Carborundum, it is not an allotrope of carbon, it is silicon carbide. See guys, the explanation if you want. Carborundum is silicon carbide, so it's not a allotrope of carbon. Remember, 4 allotropes of carbons are diamond, graphite, fullerene and graphene. These are the 4 allotropes of carbons. So carborundum is a silicon carbide, but it is not a allotrope of carbon, remember. The first organic compound synthesized in laboratory is urea. This was synthesized by German chemist Friedrich Wehler. Prepared a urea in laboratory in the year 1828 from the ammonium cyanate. From ammonium cyanate he have prepared urea. Urea formula NH2CO NH2. Already you know that. Ortho and paranitrophenols can be separated by steam distillation, because paranitrophenol is steam volatile. Paranitrophenol is steam volatile due to intramolecular hydrogen bond, while orthonitrophenol is not steam volatile. So easily you can go for steam distillation. Paranitrophenol is first taken out, then orthonitrophenol. Easily they can be separated by steam distillation. The number of sigma bonds and pi bonds present in benzene is, benzene contains 3 double bond, therefore 3 pi bond. This is clear. 3 pi bond means remaining carbon. 6 carbons are there. Between 6 carbon you are having 6 sigma bond, carbon sigma bond, and 1 hydrogens are there for each carbon, therefore 6 carbon hydrogen sigma bonds. So total 12 sigma bonds and 3 pi bonds. See there, 6 sigma bond between carbon and carbon, 6 sigma bond between carbon and hydrogen, 6 double bonds because 3 double bonds, hence 3 pi bonds. Total is 12 sigma bonds, 3 pi bonds. The region closest to Earth's surface is troposphere. Remember, a troposphere is a layer closest to Earth's surface in which all weather occurs. Fill in the blanks type question. See there. This time this is what is very interesting. See guys, answers are also given in the bracket. You have to choose the appropriate fill in the blank word. In a dash dash mixture, the component completely mix with each other. They're asking. Completely mix with each other means it is homogeneous only. So homogeneous mixture. 17th question. Dash dash is the most electronegative element. See the options given in the bracket. Fluorine is the most electronegative element. A system having more than one phase is called heterogeneous equilibrium. 19th question. Mixture of carbon monoxide and nitrogen is called producer gas. And last one, Ethyne, remaining is only ethyne. Ethyne on cyclic polymerization gives benzene. So the answers are 16th homogeneous, 17th fluorine, 18th heterogeneous, 19th carbon monoxide, 20 ethyne. So this time you are getting 21 mark questions, 15 MCQs, 5 fill in the blanks. Very easy to you guys. So this is the happy news. So we'll talk about third main part, that is 2 mark questions. Define mole. Calculate the number of moles in 20 gram of NaOH. Amount of substance that contains Avogadro's number of particles, that is called moles, and number of moles are always equal to mass divided by molar mass. 20 gram of NaOH they have given, so 20 divided by molar mass of NaOH is 40. 20 divided by 40, if you do, you will get 0.5 moles. So number of moles present in 20 gram of NaOH is 0.5 moles. Derive the relationship between density and molar mass of gaseous substance from ideal gas equation. You know ideal gas equation, PV is equal to nRT. We're replacing n by small m divided by capital M. What is the meaning? Small n means the number of moles. Number of moles is equal to mass divided by molar mass. Therefore, m divided by capital M. So PV is equal to m divided by capital M into RT. Rearranging the terms, you take capital M left hand side, PV that side. So capital M is equal to m by V into RT divided by P. And m by V means what? Mass divided by volume. Mass divided by volume is density. So in case of m by V place, you can replace m by V by D. So what you are getting answer? M is equal to dRT divided by P. This is the final expression where D is the density and capital M is the molar mass. This is the relation between molar mass and density of the gaseous substance. Very important questions, guys. Remember. What is hydrogen bonding? Give an example of molecules which shows intramolecular hydrogen bonds. Attractive force which binds hydrogen atom of one molecule with the electronegative atom of another molecules are in the same molecules called hydrogen bonding. Electronegative atom like fluorine, oxygen or nitrogen is bonded to hydrogen. Simple. So you know hydrogen bond can be classified into two types, intramolecular and intermolecular. See, intermolecular hydrogen bonding, para-nitrophenol and water. Intramolecular hydrogen bonding, ortho-nitrophenol. Regarding clear explanation of intramolecular and intermolecular hydrogen bonding, already I have made a video. If you want see it, you can see it, guys. Already I made a video. If you have not seen that, a link is given in the description. Please go through that. Write the composition of plaster of Paris and washing soda. You know plaster of Paris means calcium sulfate half H2O. Calcium sulfate half H2O, already studied in SSLC. Washing soda Na2CO3 10H2O. This also is studied in SSLC. How is diborane prepared in laboratory? B2H6. Diborane means B2H6 prepared in laboratory, they are asking. Diborane is prepared by oxidation of sodium borohydride with iodine. Oxidation of sodium borohydride with iodine, NaBH4 plus I2. So two molecules of Na and I eliminate as the 2 NaI, H2 is eliminated, so you will get B2H6 diborane. Explain Wood's reaction. See, alkyl halide on treatment with sodium metal. Alkyl halide on treatment with sodium metal in presence of dry ether media gives higher alkane. Coupling occurs. Alkyl group couple each other. This reaction is known as Wood's reaction. You see the example. Methyl bromide treated with two molecules of sodium metal. Again methyl bromide only I have taken. NaBr I have shown with the dotted line. You see there two molecules of NaBr eliminated, CH3 connect each other. So ethane is produced from the methyl bromide. So this is called Wood's reaction. Draw cis and trans isomer of but2ene. Cis means on the same side of the double bond you will get same groups. See there, cis but2ene. On upper part of the double bond you are having CH3, lower part HH, same groups are there on the same side. This is cis and second one is trans, same groups are there on the opposite side. What is smog? Name any oxide of sulfur present in classical smog. See there, Smog is a mixture of smoke and fog. Sorry for that, the spelling mistake. You take them properly, guys. Smog is a mixture of smoke and fog. Mixture of smoke and fog is called smog. Classical smog contains sulfur dioxide. Remember, what is classical smog? Occurs in cool, humid climate. It's mixture of smoke, fog and SO2. But the gas present in the classical smog is SO2. Remember, what is smog? Mixture of smoke and fog. 3 mark questions. First question, define ionization energy. How does it vary down the group? Write IUPAC name of an element whose atomic number is 106. Ionization energy required to remove the electron from the neutral gaseous atom. Ionization enthalpy of an element is defined as energy required to remove the outermost electron from an isolated neutral gaseous atom. Already studied. And how does it vary down the group? Increases across the period and decreases down the group. Why it decreases down the group? Because as you go down the group, size increases. The force of attraction between outermost electron and nucleus decreases. So you can give small amount of energy also, it will be eliminated. Electron can be ejected. So what is the case? So if size increases, energy required to remove the outermost electron decreases. Why? Because force of attraction between nucleus and outermost electron decreases. Write IUPAC name of element whose atomic number is 106. In 106, one number, the root word used for 1 is un. Root of 0 is nil, and root of 16 is hexium. So total name is unnil hexium. IUPAC name. Explain shape of ammonia molecule based on VSE pair theory. Nitrogen is atomic number 7, 1s2, 2s2, 2px, 2py, 2pz. 2p3 is there, that only I have splitted and written there. Nitrogen has 1 lone pair and 3 bond pair in ammonia. Due to greater repulsion of lone pair bond pair compared to bond pair, the tetrahedral bond angle is distorted to, usually it should be 109 degree, but it is distorted to 107 degree due to a lone pair bond pair repulsion. Ammonia has trigonal pyramidal shape. It is given like this as shown below. See guys, trigonal pyramidal, and bond angle should present as a 107, but instead of 109. This is because bond pair and lone pair present on the nitrogen. Repulsion is there between the lone pair and bond pair. Explain sp hybridization by taking barium chloride as an example. See, barium atomic number 4, 1s2, 2s2 ground state. In excited state 1s2, 2s1 and 2px1. One of the electron jump to p orbital. In an excited state, beryllium undergoes sp hybridization to give 2 sp hybrid orbitals, which are oriented in opposite direction. Overlaps with half-filled orbitals of chlorine atom along the axis to form 2 barium chloride sigma bonds, just shown in the below. BeCl, sp hybridization. Lithium molecule, write the electronic configuration. Lithium 2 molecule. Electronic configuration of lithium 2 molecule. So 1 lithium contains 3 electrons. So 2 lithium contains total 6 electrons. See the electronic configuration. This question is based on MOT, guys. Already studied in chemical bonding. If you have not seen the video, the link is given in the description. Please go through it. Sigma 1s2, sigma star 1s2, sigma 2s2. Bond order is equal to number of electrons in bonding molecular orbital minus number of electrons in antibonding molecular orbital divided by 2. So 4 minus 2 divided by 2 is 2 by 2 means 1. Bond order is 1 means lithium, between lithium and lithium 1 bond is present. And you remember, you see the electronic configuration, there is no unpaired electron, all are paired, hence it is diamagnetic. No unpaired electron, therefore it is diamagnetic. I hope you understood the question. Balance the following redox reaction by oxidation number method. So this type of question guarantee you are going to get in annual examination. One question for 3 mark. See the given acid medium is given MnO2 plus Br minus give rise to Mn2 plus Br2. First step, what to do? First given reaction I have written. Step 1. Same reaction I have written, but MnO2 and Mn. See the oxidation state of MnO2, Mn in MnO2. Oxygen is -2, so 2 oxygen means -4. Oxygen -4 means Mn should be +4. So earlier in the reactant stage, Mn is +4 oxidation state. In product state, the Mn is +2 oxidation state. So decrease in oxidation number by 2 units. It is called reduction. And Br minus to Br0. So -1 to 0. Increase in oxidation state by 1 unit. So it is oxidation. That is, Mn is going to reduce, Br is going to oxidize. Step 2. MnO2 to Mn plus as it is, because only one Mn is there left side, one Mn is the right side. But Br minus to Br2. See, left hand side 1 Br is there, right hand side 2 Br are there. Therefore, left hand side we have multiplied with 2. 2 Br minus give rise to Br2. Step 2, I hope you understood. There is not necessary to multiply any number here. Only Br minus you have to multiply by 2, because right hand side Br2 is there. 2 Br are required for left hand side. So therefore we have multiplied with 2. Step 3. MnO2 plus 2 Br minus Mn plus 2 plus Br2. So whatever you have written, the combined form I have written. Step 4. Balance the oxygen atoms now. How to balance the oxygen atom? By adding water on the RHS side. And if you add a water, again number of hydrogen should be less in the LHS side. So acid medium is given. Therefore balance the hydrogen atom by adding 4H plus on the LHS side. 4H plus LHS side, 2 water RHS side. So balanced chemical equation is MnO2 plus 2 Br minus plus 4H plus give rise to Mn plus 2 plus Br2 plus 2 water. So clear explanation if you want. So 5 problems, already this type of problems I have solved in the video of redox reaction. If you have not seen that, the link is given in the description. First go through that, guys. What are covalent hydrides? Give an example. Name the isotope of hydrogen used in the nuclear reactor. Covalent hydrides, they are binary compounds of hydrogen with group 13. Binary compounds of hydrogen with group 13 to group 17 elements. Examples are BH3, CH4, NH3, etc. Covalent hydrides. Deuterium is used in the nuclear reactor. Deuterium is an isotope of hydrogen which is used in the nuclear reactor. Give any 2 reagents for anomalous behavior of beryllium. Complete the reaction. See, beryllium is behaving differently as compared to other elements of the same group, because beryllium is having small size, it is having high ionization enthalpy and absence of d orbitals. These are the 3 main reasons due to which beryllium behave different, that is anomalous behavior of beryllium. 2 Na plus O2 means they are asking for when sodium metal is kept open in air. It undergo oxidation to form Na2O2. It catches fire only. In air, sodium metal burns vigorously to form peroxide, Na2O2. Sodium peroxide is formed. Write any 2 difference between graphite and diamond. Name the gas which forms complex carboxyhemoglobin. They are asking difference between graphite and diamond. Diamond is hard in nature, graphite is soft. Diamond, the carbon atom is sp3 hybridized. In graphite, the carbon atom is sp2 hybridized. In diamond, bad conductor of electricity. Graphite, good conductor of electricity. Diamond is colorless, graphite is gray color. Diamond is transparent, graphite is opaque. So these are the 5 difference between the diamond and graphite. Very important question, guys. Second question, name the gas which forms complex carboxyhemoglobin, that is carbon monoxide. Carbon monoxide can form poisonous complex carboxyhemoglobin in red blood cells. Last case, part D. In part D again 2 parts are there. One is physical part and another one is organic part. See there, 4th one is a physical part. You have to answer 4 questions. An organic compound contains 4.05% hydrogen, 24.26% carbon, 71.67% chlorine. Its molecular mass is 98.96. Find its empirical formula in molecular formula. Atomic mass of hydrogen is 1, carbon is 12, chlorine is 35.45. So, this type of question, guarantee question, 100% guarantee question in annual examination, guys. So properly you do this type of problems. If you have not seen the video of these problems, already have made a video on this problem, also some basic concept of chemistry, important questions with answers. The link is given in the description. Please go through that. Yes, let us discuss. And second question, define molarity. So first I will define molarity. Afterwards we will talk about the problem. Defined as, molarity is defined as number of moles of solute present in 1 kg of solvent. Number of moles of solute present in 1 kg of solvent, it is denoted by small m. Let us discuss about the problem. See, you have to make a chart like this. Element percentage composition given to us, atomic mass given to us. Then we have to calculate the ratio between percentage of composition divided by atomic mass. Then number in the previous column divided by least number. Then total simple whole number ratio. See, element is hydrogen, carbon, chlorine. Compositions, percentage compositions are given in the questions. I have written the same. Atomic mass are also given in the question, written the same. Percentage composition means second column and third column we have to divide. 4.07 divided by 1.008. You will get 4.0376. Similarly, you go for 24.27 divided by 12, you will get 2.0226. 71.65 divided by 35.5, you will get 2.0183. So next column is number in the previous column divided by least number. Among the three answers we got, what is the least number we have? 2.01. So 4.0376 divided by 2.0183. You will get 2 exactly. Similarly, second one 1.002, third one 1. So last column, simple whole ratio. 2.00 means whole ratio is 2. 1.002 is means whole number is 1. So last option is we are getting 1 only, 1. So 2 hydrogens, 1 carbon, 1 chlorine. Therefore empirical formula is CH2Cl. To calculate molecular formula, small n value should be calculated, and the small n value is equal to empirical formula mass divided by molecular mass. Empirical formula mass, 2 hydrogens 2 into 1 plus 1 carbon 1 into 12 plus 1 chlorine 1 into 35.46. So total answer is 49.45 we are getting. What are we getting? 49.45. Sorry for the 17. 17 will not come, guys. So only 49.45 we are having. So n is equal to, sorry for the mistake had happened here, some technical mistake. N is equal to empirical formula mass, sorry, molecular mass divided by empirical formula mass. Molecular mass is given in the question 98.96 divided by, for empirical formula mass, 49.45. So total answer is 2.001 is equal to 2. You scratch the 17 given there. It is wrong, guys. Sorry for that. Some typing mistake is there. Therefore, molecular formula is empirical formula into small n. Small n is 2. Empirical formula is CH2Cl into 2. So 1 carbon becomes 2 carbon. 2 hydrogen becomes 4 hydrogen. 1 chlorine becomes 2 chlorine. So total formula is C2H4Cl2. This is a molecular formula. So very important question. 4 mark. Definitely you are going to get an annual examination. Guaranteed question this time. And usually they will ask same question. Give any 3 postulates of Bohr's model of an atom. State Pauli's exclusive principle. Write electronic configuration of chromium. Postulates of Bohr's atomic model. Electron revolve around the nucleus in a definite circular path. As long as electron revolve in the particular orbit, it does not emit energy. Only these orbits are permitted in which angular momentum of electron is an angular multiple of h by 2 pi. MVR, angular momentum, MVR is equal to NH divided by 2 pi. So these are the postulates of Bohr's atomic model. Already you studied in structure of atom. If you have not seen the video, the link is given in the description. Please go through that. Second, B, Pauli's exclusive principle. It states that no 2 electrons of same atom can have all 4 quantum numbers same. Meaning is the no 2 electrons of the same atom do not have all 4 quantum numbers same. All 4 quantum numbers should not be same for any 2 electrons of the same atom. That is what given by Pauli's. Electronic configuration of chromium, atomic number is 24. Argon 3d5 4s1. Correct electronic configuration. The green light has a wavelength of 535 nanometer. Calculate the energy of photon of green light. Explain significance of all quantum numbers. This is very important question, guys. In almost all of the previous annual examination, this question is repeated. See, green light has a wavelength of 535 nanometer. Calculate energy of the photon. E is equal to h nu. We have the formula. The given data lambda is equal to 535 nanometer. If you want to convert into meter, 535 into 10 power minus 9 meter. And E they are asking. We have E is equal to h nu. H into nu means frequency. So you can write C by lambda. So what is the formula we got? E is equal to hc by lambda. H value is 6.626 into 10 power minus 34 joule. C value is 3 into 10 power 8 meter per second, divided by lambda value is 536.35 into 10 power minus 19 meter, minus 9 meter. So if you divide everything and if you get 0.0371 in 10 power minus 17. So if you want to take 2-digit right hand side, you have to multiply with minus 2, 10 power minus 2. So what is the total answer you are going to get? E is equal to 3.71 into 10 power minus 19 joule. I hope you understood. Only E is equal to h nu formula you have to remember. In place of nu you have to substitute C by lambda. Simple. Significance of all quantum numbers. This question is very, very important, guys. So many times annual examination same question is asked. Principal quantum number. It is specifies the size and energy of the orbital. Its values are 1, 2, 3, 4 starting from 1, natural numbers only. It specifies the size and energy of the orbital. Remember, denoted by small n. Azimuthal quantum number denoted by small l. It indicates 3D shape of the orbital. Magnetic quantum number denoted by small m. It indicates the orientation of the orbital in space. Principal size and energy, azimuthal 3D shape, magnetic orientation, spin quantum number, spin of the electron. Its value is plus half or minus half. Very important question. Remember, principal denoted by small n, size and energy. Azimuthal quantum number small l denoted by 3D shape. Magnetic quantum number small m denoted by orientation of the orbital. Spin quantum number small s, spin of the electron, plus half or minus half. Write any 3 postulates of kinetic theory of gases. Mention 2 conditions at which real gas approach ideal behavior. So this question is also very important, guys. So many times the annual examination same question is asked. See, 3 postulates of kinetic theory of gases. See, gases are made up of large number of small particles called molecules. Volume occupied by gas molecule is negligible as compared to total volume of the gas. There is no loss of kinetic energy during the collision. Average kinetic energy of the gas molecule is directly proportional to the absolute temperature. So already I have explained each point in the states of matter chapter. Already I have made a video. If you have not seen this video, please go through the video. Link is given in the description. Mention 2 conditions at which real gas approach ideal behavior. So at which condition real gas behave like a ideal gas they are asking. And you know, low pressure and high temperature real gas behave like a ideal. State first law of thermodynamics, write its mathematical form in the adiabatic process. Gibbs equation and mention any 2 thermodynamic criteria for the reaction to be spontaneous. First law of thermodynamics, energy can neither be created nor be destroyed, but it can transfer from one form to another. This is first law. Mathematical expression is del U is equal to Q plus W, where del U is change in internal energy, Q is heat, W is work done. Gibbs equation, second option B question they are asking for Gibbs equation. Delta G is equal to delta H minus T delta S, where delta is G is change in Gibbs free energy, delta H is change in enthalpy, T is temperature, delta S is change in entropy. Thermodynamic criteria for reaction to be spontaneous, change in enthalpy should be negative, delta H should be negative, and change in entropy should be positive. Delta S should be positive. So when the reaction is spontaneous, when delta G is negative, when delta G is negative, when delta H is negative and delta S is positive. That case only delta G is negative. So this is what case at which thermodynamic criteria for the reaction to be spontaneous. Combustion of 1 mole of benzene takes place at 298 Kelvin and 1 atmospheric after combustion. CO2 and H2O are produced and 3267.0 kilojoule of heat is liberated. Calculate the standard enthalpy of formation, delta H naught of formation of benzene. Standard enthalpy of formation of CO2 and H2O are given minus 393.5 kilojoule per mole and minus 285.83 kilojoule per mole respectively. They are asking what is the standard enthalpy of formation of benzene. Same question is there in the NCERT, guys. 6.9, problem number 6.9, thermodynamics chapter. It is there in the NCERT. They have solved. If you are unable to identify or unable to understand the problem, please comment in the comment section. I will try to make a video on this problem also. This problem also guarantee you are going to get an annual examination and you will get same problem. I will guarantee you, guys. Define entropy. See problem number 6.9 in the NCERT textbook, thermodynamics chapter. Second B, define entropy. It's a measure of randomness or disorderness of the system. That is called entropy. See the question. State Le-Chatelier's principle. What is the effect of temperature on equilibrium? 2NO2 gives rise to N2O4. See the delta H value minus 57.2 kilojoule. Meaning is delta H is negative means forward reaction is endothermic. Then backward reaction should, delta H is negative means forward reaction is exothermic. Heat is liberated during the process. If forward is exothermic, backward is endothermic. Remember. So what is Le-Chatelier's principle told? If a system in equilibrium is subjected to constraint or conditions such as change in temperature, pressure or concentrations, then equilibrium is so shifted as to nullify the effect of the constraint or condition. What is the meaning? So meaning is if you increase temperature, system tries to decrease temperature. If you decrease temperature, system tries to increase temperature. If you increase pressure, system tries to decrease pressure. If you increase concentration, system tries to decrease concentration. This is what given by Le-Chatelier's. See, forward reaction is exothermic because delta H is negative. Then backward reaction is obviously endothermic. Forward is minus means backward should be delta H is positive. Now they are asking effect of temperature. We'll get two cases, increase in temperature and decrease in temperature. See, if temperature is increased at equilibrium, system tries to decrease the temperature by absorbing heat. So by absorbing heat means which process it is endothermic and backward reaction is endothermic. Therefore backward reaction is favored. If temperature is equilibrium shift to left side. If temperature is decreased at equilibrium, system tries to increase temperature by liberating heat. Liberating heat means forward reaction which is exothermic is favored. Equilibrium shift to right side. Very important. They are asking acid and base according to Lewis acid concept. Lewis acid is an electron pair acceptor. Electron pair acceptor is called a Lewis acid. All electron deficient molecules, boron family BF3, AlCl3 are Lewis acid and all positive ions are Lewis acid. Base is electron pair donor. All electron rich molecules having lone pairs H2 and H3 and all negative ions comes under Lewis base. Lewis acid is electron pair acceptor. Lewis base is electron pair donor. Remember. Write the relationship between H3O plus and OH minus for neutral solution at 298 Kelvin. Solubility and solubility product of AB type salt. What is buffer and some problem is given. See first question, write relationship between H3O plus and OH minus for neutral solution. For neutral solution, H3O plus OH minus both are equal and equal to 10 power minus 7 because for neutral solution pH is 7. So pH is 7 means molar concentration of hydronium ion and molar concentration of hydroxyl ion both are equal and equal to 10 power minus 7 mole per liter. Solubility and solubility product, relation between solubility and solubility product of AB type salt. So already I have made a video on equilibrium. If you have not seen, go through the video. The link is given in the description. You will come to know how to get the solubility and solubility product. So solubility product is denoted by KSP, solubility denoted by S. For AB type crystals, you see it, KSP is equal to S square you are having. Correct? Yes. KSP is a solubility product constant, S is a solubility. Then they are asking what is buffer solution. The solution which resists change in pH value upon adding small amount of acid or alkali. See, the solution which maintain the pH constant after adding small amount of acid and base also, the pH is maintained constant only. Such type of solutions are called buffer solutions. Right. Problem you see, pKb minus log Kb minus log 1.77 10 power minus 4 5. So Kb is given to us. Using Kb you can calculate pKb. The value is 4.7520. We have POH is equal to pKb plus log of salt divided by base. Henderson-Hasselbalch equation. 4.7447 plus log of salt means NH4Cl, value is given 0.05. Base means NH4OH, value is given 0.025. It is given in the question, guys. So when you divide 0.025 divided by 0.025, you will get log 2. Log 2 value is 0.3010, and you add it, you will get 5.045. That is POH. I hope you understood the problem. If you are not getting also, please comment below. Already I have made a video also. If you can go through that video, the link is given in the description. Last part, answer any two of the following. So these three questions are given with organic chemistry. How to answer any two. And out of two organic chemistry chapter, three organic chemistry chapter, organic, some basic principles of organic chemistry chapter is there now. There you will get 2 5-mark questions. So if you can read only one organic chemistry chapter also, you can get out of what marks. See there, how carbon and hydrogen in organic compounds are estimated by Liebig's method. Already I have made a video. So if you have not seen that, link is given in the description. You please go through that. So in NCERT also it is given. Read from the NCERT, guys. Read from the NCERT textbook, Liebig's method. Give any two difference between inductive effect and resonance effect. See the differences. Inductive effect, electron moves through sigma bond. Resonance effect, electron moves through pi bonds and lone pairs. Inductive effect occurs in saturated compounds, means single bonded compounds. Resonance effect usually occurs in unsaturated compounds, doubly bonded compounds. Inductive effect is based on property of electronegativity. Resonance effect is based on property of conjugation. Inductive effect is transmitted over short distance, only up to 2 to 3 bonds, but resonance effect is transmitted along the long range in the entire molecule. So this is regarding difference between inductive and resonance. So if you want to study the difference between inductive and electromeric, inductive and mesomeric, already I have given a video. The video is already there in this channel. If you want to see that, the link is given in the description. Please go through that. Define functional isomerism. Do alcohols exhibit functional isomerism with ether? Yes, it is. See, two compounds having same molecular formula but differ in the functional groups are called functional isomers, and the phenomenon is called functional isomerism. Alcohols and ether exhibit functional isomerism. Yes. Examples are, see there, diethyl ether and ethanol. See the ether formula, 2 carbon 6 hydrogen 1 oxygen. Ethanol formula, 2 carbon 6 hydrogen 1 oxygen. Molecular formula is same, but functional group is different. Such isomers are called functional isomers, and the phenomenon is called functional isomerism. See the second question B. Give an example of each neutral, electrophile and nucleophile and electrophile. See, neutral, nucleophile, nucleus loving, the compounds which contain lone pair of electron like ammonia and water. Electrophiles which accept electron loving, so electron deficient species like BF3SO3. These are the examples. Now they are given with CH2 double bond CH single bond CH double bond CH2. They are asking bond line formula. You know, carbons are shown by dotted line in the bond line formula. You are not supposed to write hydrogen and carbon. Only you are shown dotted line and lines. So the bond line formula for above diagram is this one. So if you want more examples, already I have made a video of organic chemistry first chapter. The link is given in the description. Please go through that. Last question of this model question paper. Explain mechanism of chlorination of benzene. This is also very important question, guys. So many times it is asked in the annual exam. See, benzene on treatment with chlorine. First we'll write the reaction. Benzene on treatment with chlorine in presence of chlorine carrier like PCl3. You got chlorobenzene plus HCl. How it occurs? It occurs in 3 steps. Step 1. Generation of electrophile. See there. Chlorine react with PCl3 to give Cl plus and PCl4 minus. Cl plus is a electrophile. Now Cl plus is going to attack on benzene. Carefully see. Step 2. The electrophile Cl plus attacks the benzene ring to form carbocation, which is resonance stabilized. See the reaction. The electrons are there with a benzene. Electrons are given to Cl and form a carbon Cl bond. Double bond is broken. Positive charge on carbon atom. Therefore, it is called a carbocation. Third step, loss of proton to give chlorobenzene. Last step, loss of proton to give chlorobenzene. See there, PCl3, HCl and chlorobenzene you will get in the final. So starting you have used PCl3 as a catalyst. Finally you got PCl3 outside. Means PCl3 do not involve in the chemical reaction. It only increase the rate of the reaction. It acts as a catalyst. This is regarding mechanism of chlorination of benzene. If you are not getting the mechanism, please comment below. I will make one more video. So on that I will explain clear picture regarding mechanism of chlorination of benzene, nitration of benzene, halogenation of benzene, everything, right? See this B question. In B question they have asked for how bit 2 wine is converted into bit 2 ene, triple bond to double bond. See, it is called Birch reduction. H2 palladium over carbon in presence of quinoline as a solvent. See there I have given a reaction also. So this reaction is called Birch reduction, guys. So from the Birch reduction, if you use quinoline, H2 palladium over carbon, cis alkenes are formed, cis but 2 ene. If you want same thing with a trans, then you have to use again Birch reduction only, but instead of palladium carbon, you have to use liquid ammonia. And quinoline is not used. H2 and liquid ammonia you are using there. That is also Birch reduction only, but you will get trans product at that time. So if you use palladium carbon over quinoline, you will get cis product. If you want trans product, you have to use liquid ammonia. That is also called a Birch reduction. Chloroethane to ethene, alcoholic KOH. When you treat with alcoholic KOH, chloroethane is converted into chloroethene. Only they are asking for reagent. I have written the reaction also. I hope you understood. So this is regarding this session, guys. So if you got any doubts, I hope this video is helpful to you guys. If it is helpful, please share among your friends so that every student can get a benefit of it. And on which chapter you want a video, please comment below, guys. In upcoming days, so within 15 days, we'll complete the entire first PU, all chapter wise important questions with new pattern. So if you want, you can comment below, guys. If you want mathematics also, you can comment below. I will try to make a video. Yes, if you got any doubts, please comment below. I hope this video is helpful to you. Thanks for watching. Thank you.